Okay, so today we are going to discuss about gradient boosting and XG boosting. Okay, after that we will also going to learn about the basics of unsupervised machine learning. Okay, algorithm wise tomorrow we can discuss, but today we will explain. I mean, we are going to learn about what exactly unsupervised learning and how does it works and what are the algorithms there and what we are learning a part of unsupervised learning. Okay. First, gradient boosting is what really important to understand. So let me highlight that particular gradient boosting, gradient descent. Okay. Okay. This is actually, gradient descent is actually a basic thing. Okay. So you have to go through it as a self study. It is very decent topic. Anyway, we will discuss this in deep learning. We will touch this gradient descent in deep learning. But before that, we are now going to learn about this XG boost. Oh, just a second. Somebody trying to join, I guess.
Recording? Are you recording the session, Harsha?
Yes, yes, yes. I started the recording. Yeah, I started the recording. Okay. Gradient descent. Anyway, we will discuss this in somewhat little extension version. We will discuss in deep learning. But anyway, if you are interested, you please go through this gradient descent. So now in this, but why are giving this is it is a kind of a basic how a loss function actually works and how it will choose the minimum. Okay. So actually what it does is it is an optimization algorithm, first of all, and it is mainly used to train machine learning model by adjusting parameters. Okay. Whatever the parameters they have, this algorithm will adjust their parameters to minimize the error, to minimize the loss. Basically, error means I already mentioned you error is inversely proportional to loss. If loss is less, higher error, accuracy will be more. Error is simply sorry, accuracy is inversely proportional to error. Error is less means accuracy is more. That is why it targets all about minimizing the error. Okay, it only focuses on to how to minimize the error. Okay, and why do we require, why it required to minimize the error? I just told you, because we will get the high accuracy. Those two are always inversely proportional to each other. By the way, what is error? Don't confuse, because we are now we are from Monday onwards, probably we are going to start, we are going to enter into deep learning neural networks. There again, keep on we touch about error. Error is something like prediction minus actual. Okay, prediction minus actual, that difference should always, we are expecting it a minimum. Okay, so our goal is to reduce that minimum. Okay, so one of the algorithms that will help us to do that iteratively is what gradient descent. It is like, for example, if you are imagining climbing down a hill to reach the lowest point, global minima, that is called global minima. Okay, so there is a concept actually in mathematics, if you want you can refer local minima and global minima. Okay, global minimum is the bare minimum, the last tip point, that is what lowest point. Okay, what are the steps involved in gradient descent means? First of all, we need to initialize the parameters. We'll start with random values for model parameters like weights and biases. Weights are something like coefficients. Okay, and compute the loss. We will compute the loss. Loss means we can take the mean square error. Okay, regression, we will take the mean square error, right? So something like that. Then we will update the parameters, then find again slope of the loss function and update the parameters by moving them in the opposite direction of the gradient. Okay, I will show you how exactly gradient is look like, like this. Okay, sorry, like this. So we will start it here and we will go down. Here we will get the minimum. From again, if you start, keep on and it will get even increasing. So this is the point what we really want. Okay, so update the parameters and again check, and until we get the least minimum we will keep on go. The formulation is like this: the new parameter will be decided by old parameter minus alpha. Alpha is what? Learning rate. This can be any points between 0 to 1, 0.5, 0. Usually it starts with 0.1. Sometimes people always experiment this parameter. That is why we use this in hyperparameter tuning. Okay. And L is nothing but loss function. Whatever the loss function you consider, that is what we have to do, the derivation of the loss function with respect to theta, and then multiplied with loss this learning rate. That is what will be subtracted out of subtracted from the old parameters. We will get the new parameter. We will update those new parameters, and then we will again uh, try the slope, and then wherever we get the less error, we will stop there. Okay, you might have a question, right? How exactly this works means, let me say, for example, y is equal to mx plus c formulation is there, where m is the slope. Okay, so if this parameter set properly, then we can get the perfect fit line, and these two basically. Okay, these two are very important even in multi uh, parameters like beta naught plus beta 1 x1 beta 2 x2. Let us say three input features are there. Okay, three input features are there. Then beta 1, beta 2, beta 3 are called the parameters, also referred as theta 1, theta 2, theta 3. You can mention anything. These parameters are really important. This plays a crucial role to get the y value. If we get the y value, we can compute this y minus y prediction. This is what the y prediction. This is called y hat or y prediction, this formulation. We will get the predicted value. We anyway have the actual value from the data set, and square it, so that, and then mean it divided by total number of, so that we will get the, okay, 1 by n, I is equal to 1 to n, okay, y minus yi minus y hat whole square will gives you the mean square error. Here what gradient descent works is, here first it will consider theta 1, theta 2, theta 3 and calculate the error. No, we did not get the minimum error. We still had to minimize it. Then what will happen? This theta 1, theta 2, theta 3 will update. How this will be update? Theta new is equal to theta old value is there, right? Minus alpha times of dou L by dou theta. If you compute like this, then you will get the updated value, and again try the y is equal to beta naught, beta 1, beta 2, beta 3. Update value, you update these values, and again try y hat, means y prediction. And you again calculate the mean square error and check whether it got reduced or not. It will reduce, reduce until unless you reach the, this is what global minimum. Global minimum is, this is the last point, and this is the least point that what we get. After this, again it will get raised. So this is the where we have to stop our algorithm, and these points are the fixed ones. This way we will get the most optimal result. This is how gradient descent works. Is this clear how gradient descent works? Anyway, I would like to cover it in deep learning, but here itself I discussed. Is this clear?
Yes, yes,
Gradient descent, how
Roshan.
exactly it works? Very good.
Yeah,
If you
somewhat.
want, yeah, what, Maria?
Somewhat it's clear, yeah.
Yeah. So by doing this, what we will get? The ultimate goal is to get the minimum error by by adjusting the parameters. Keep on adjust their parameters so that we will get the minimum error. Once we get the minimum error, means obviously we'll get the higher accuracy. Then the second concept is gradient boosting. Okay, gradient, see, XG boost is something like extreme gradient boosting, means advanced version of gradient boosting only. First of all, we need to understand gradient boosting. We understand gradient descent. Now we understand, we have to understand the gradient boosting algorithm. Yesterday, what I discussed to you is, there are three types of ensembling methods are there, right? Ensembling. By the way, let's refresh our memory. Ensembling is useful for, I mean, it will help us to first of all, reduce the effect of overfitting or underfitting. And then main important thing is we can improve our accuracy. Our main goal is to improve the accuracy, right? Our main goal is improve the accuracy. Main goal is to improve accuracy. Accuracy. To improve the accuracy of any algorithm, what can we do? Ensembling technique we can go for. Ensembling. Inside ensembling, there are three types. One is bagging. Second one is called stacking. Third one is called boosting. So these two, bagging and boosting, homogeneous models. Remember this. This is heterogeneous models. Heterogeneous. What is meant by hetero? Means different, right? Homogeneous means we know that it is same. Somebody trying to join, let me join in, or else somebody is having any question. No, Gyanesh wanted to join. Hello, Gyanesh. Yeah. So there are three types. As I mentioned, ensembling are having three types: bagging, stacking, boosting. Bagging and boosting requires homogeneous models. Stacking means heterogeneous models. Stacking means simply, yesterday anyway I covered, again refreshing your memory. Stacking means different algorithms will be taken on the same data set. Data set is same. Here model 1, algorithm 1, let us say. Algorithm 2, algorithm 3. We will combine algorithms and we will decide the decision. We will take a decision. If it is classification, simple, you need to understand majority. Mode, also called as. Okay, if it is regression, we will consider all three values and then mean, aggregated mean, and then that is what the result, prediction value. Got it? This is what stacking. Then bagging and boosting are very popular. You might have came across many algorithms in Kaggle or any other way in GitHub and all. Bagging and boosting algorithms are common than stacking. Okay, but you can try any one of these three to get improve your accuracy. Okay. Let us now discuss about what are these two. Then we will cover the gradient boost. I mean, the yes, gradient boosting. Okay. So first is bagging. Anyway, yesterday we covered algorithm is random forest. Simple it is. We will take a base model. Base model data set will be there, right? Data set. What concept here we will use is randomization. What randomization? Bootstrap. Remember this concept, bootstrap. Bootstrap means random selection with replacement. We can take some random points from dataset and feed it to model 1. Model 1 means same model, whatever model we are choosing here. Usually many people select here decision tree. It is not that you always have to choose decision tree, it is your choice. Okay, decision tree. For example, if you use decision tree, next time again also you have to use decision tree only, because it is concept of homogeneity, right? This is homogeneous, means same algorithm we have to use second time, and we will get model 1 output 1. Again random points feed it to again decision tree second algorithm, we will get again second output 2. Similarly, in how many number of times you want to use randomly how many times you want to use decision trees, accordingly your outputs will be calculated. And again, majority is what considered here in classification, aggregation is what considered here in regression. This is clear. Now we are now have to discuss boosting. Yesterday I already told you what exactly boosting, but again, let me cover that point. Like bagging, boosting is again data set will be there. This is what data set. Here we will take randomized bootstrap samples, some random samples we will take here. This is base model. Whatever the base model, for example, decision tree is the base model. Remember that. So you have to use the same model. So we will get one output. Output means we will get number of predictions. How many? I mean, accuracy will be there, no? Or else error, also called as
Yeah.
residuals. Residuals, also called as errors. We will calculate error, and that error is feeding. That error is feeding again with the data set. That is feeding to the again sequentially to the decision tree second. second algorithm, we will again get errors. That again we will feed it to the decision tree along with the data set. Okay. So that continuously how many times we consider the trees, that many ways we have to consider. And finally, we will get an output. That output is fixed here, no majority, because now we are not considering calculating three different ways. Now we are clubbing all them to next tree, and then next tree passing out, and final output is what we are considering. Okay, this is what generally boosting algorithm. Here you need to remember it is a sequential operation, and in bagging you need to remember that is parallel operation in bagging. In boosting it is sequential. So one on one, right? One by one is was sequential. Now let us try to understand our important algorithm, which is gradient descent. Gradient descent. Here what happened is same. This is boosting. Boosting means how it works. You need to memorize that thing. Boosting means just now I explained. It is like we have to pass it to the next algorithm, again pass it to the next algorithm. How many decision trees we take, that many times it will pass, and then we will get the output. Gradient boosting, see, observe this one. Okay, gradient boosting. I will explain this later, but first let me explain you in pictorial way. I mean, in easy way, so that it will easy to understand that particular picture. Okay, first let us consider you are having a training data. Training data. I mean features, input features. These are all input features. Okay, these are all input features. X1, X2, X3, X4. We are having Y column. You know Y column, right? Y means output column. Okay, these are all inputs. This is output. This is Y column. Okay, so we have to pass this X and Y to base algorithm. Base algorithm, if I choose decision tree, then decision tree. Okay, I will get Y hat, right? Y hat means predictions, correct? So I will get predictions. If I pass X train and Y train, I will pass the X test to the decision tree. Then I will get the Y predictions. So from Y predictions, what I can do, I can get the errors, residuals. This is called Y hat. Y hat 1. Let us consider Y hat 1 first time. We will get some values. Okay, we will get some values. So use these values. Okay. And next time, this is what first decision tree. Got first decision tree. When we are going to the second decision tree, second time, what we will do is we will use these values x input values again, but instead of this y value, we will give this y value. Got it? We will use this y value, and we will ask our model to again give one more predictions, that is y2 hat. Let us consider here y1 hat, and we will ask one more time y2 hat. Next time again we will again pass this y2 hat along with x values to give again y3 hat, so that by doing these times our error will get reduced, because our true value is there. Anyway, we will compare the true value with y2 hat, so comparatively somewhat less error, and again y3 hat comparatively with less error. By doing these times sequentially, we will get the final output value most affected way. But here you need to understand one thing. So if we don't add learning rate means lambda, okay, hyperparameter. If you don't add this lambda, you may encounter overfitting. You may encounter overfitting. So that is why the formulation is lambda times it will be. Earlier we saw in gradient descent also, right? Theta and old minus alpha times of dou L by dou theta. Because why this alpha? Because if you don't include this, you may encounter the overfitting problem. In order to avoid that, statisticians prefer to add an alpha between 0 to 1. Then what value I have to fix it? It is a hyperparameter. You can test it with 0.1, 0.2 or 0.01. It is up to you. You can choose some 5 different set of parameters and again try wherever you get the higher accuracy, that combination you can fix. This is how it works. Okay, is this gradient descent, sorry, gradient boosting is clear? This is the concept of gradient boosting. Is this concept clear? Can I get a quick confirmation?
Yes.
Clear, right?
Yes,
Okay.
Yashwant. It's clear for me.
Yeah, very good. I hope it is also clear to all of you. So if not means, please let me know. If yes means, we can continue. Can I get a quick thumbs up from others? Yeah, good, Ranjit. Okay. Okay. So now it is very easy to understand for you. See, y hat 1 we got. So let me use another color so that it is easy to present. So y hat 1, you can see we will get the f1 of x1 means first time we got something. Y hat 1, y1. Then what we will do, y hat 2 is something like we will this particular thing along with the x parameters. Got it? Along with x, the y value is the one we got it from the first time decision tree output values, error values. Then we will get like this. Okay. So now we again have to consider error. That is what f2xi. That f2xi again have to pass it to the next time along with previous error. Then we will get that times how many times you want, 3 times, 4 decision trees or 5 decision trees. It is up to you. Finally, we get the desired value and accuracy will be more. That is the concept of you know gradient boosting. And there is one more picture I just wanted to add. Hmm. Let me zoom in. Yeah. So here you can see the same thing. Now it is very easy. Data feeding to decision tree 1. We will get some prediction residuals that is passing to the next time along with the input data. Then we will get again another one residuals, another one weighted data. That is what weighted data, you can see weighted. And now we will get again. So this process will repeat. And the final prediction, the predictions. And now with the help of this, what we will do, we will get the most appropriate result, accuracy. Okay. So now we can understand this XGBoost theory. Okay, because we understood gradient descent, now we can understand extreme gradient means somewhat improvement will be there in gradient descent. It's a powerful and popular machine learning algorithm, especially for the structured data, tabular data. If you have, then it is the popular algorithm. Okay, it is based on boosting. Just now we discussed. It combines the predictions of many weak learners to create a strong, accurate model. Key concepts are boosting is there, gradient boosting is there, and loss function. See, this is same concept like boosting, but gradient boosting, but it is extreme. Some more parameters it will test. And boosting we know, gradient boosting also we know. Gradient descent is the what we will use. Loss function actually it use gradient descent to minimize the error in this function, and loss function is XGBoost minimize the loss like mean square error we just now discussed, or log loss for classification. Now how exactly it works means initially a weak model start with simple prediction like average the target value, then calculate the residuals means errors, and then fit a decision tree. The new tree tries to predict the again errors, updated the predictions, add a new tree prediction to the previous one, and repeat. The main features are regularization, prevents the overfitting, handling missing values. Okay, XGBoost can handle missing values very naturally, and parallel processing is also possible. And here I just provided you the simple differences between XGBoost and gradient descent boosting. I mean, here you can see speed and efficiency wise, XGBoost is somewhat faster because it is extreme. It will consider extra parameter than gradient boosting. And regularization versus here advanced regularization like L1, L2 we already discussed. Lasso and ridge regression, we also understand how the penalty is getting added to the error so that to reduce that parameters and shrinking the parameters to overcome the underfitting and overfitting problem. And then it can handle the automatically, it will handle actually XGBoost automatically handle the missing values by learning optimal paths, because gradient descent is what it will use, right, to get the most minimum error. And it supports the parallel tree construction and pruning and a lot of things you can go through as a part of theory. And when it comes to programming, this is what really important from XGBoost. XGBoost is a second another library which is not a part of scikit-learn. And here you can use XGBoost. From XGBoost you can get XGB classifier, sorry, classifier. Then I am using here breast cancer dataset, which is a default dataset available in scikit-learn. We need not to download from anywhere. Scikit-learn also provides a lot of datasets for practice and research. So one such libraries is uh, breast cancer. Okay, breast cancer dataset. Anyway, we also dealt this concept earlier, right? If you remember, one of my classes, I covered this concept, breast cancer. Okay. And the same data set, now we are not downloading it from anywhere. We're just importing or taking from the default libraries, sorry, default data sets. Then X-train, Y-train, same. But here, I have ordered the step by step. Here, number of trees. Estimators is nothing but number of trees. How many decision trees you want? Here I consider 100, but you can club it from 5, 3, 10, something like that. Learning rate, I mentioned, right? Learning rate is really important. It can be between 0 to 1. I considered as first as 0.1. Then depth. Each decision tree, how many levels it want? 3. Subsamples, how many subsamples? And whole samples, here it is means subsamples ratio of the columns when constructing the each tree. I want 80%. Okay. Next, just use the fit so that it will get fit, and then you will get the prediction, and then your accuracy is, you can see, 96% is accuracy. Okay. Now what you can do is I will provide you this particular code. Now you have to do, instead of using XGBoost first, you have to try here X-train, Y-train. Up to now it is clear. After that, here you have to try. First, you can try with the logistic regression, then KNN, SVM, okay, random forest, and XGBoost. Then you can prepare the complete picture, which is really giving you the best ones. Got it? And understand, and also you have to practice the by changing the hyperparameters. Like you can alter the estimators, you can alter the learning rate, you can alter the max depth, you can alter the subsamples, you can also alter all such parameters, and then observe how accuracy is getting changed by do this hyperparameters tuning. Got it? This is all about XGBoost and gradient boosting. In general, boosting. Last class, we discussed about bagging. One such algorithm is random forest, which is really popular. Similarly, XGBoost is also really popular, especially we are doing it for classification algorithms. Okay, so but anyway, yesterday I told you, so you cannot take XGBoost straight away, even in reality. First of all, you try with basic algorithms and try to enhance by changing hyperparameters in that basic algorithm, and try to enhance the accuracy. If you are not able to, or if you find something else is missing to get the desired ones, then go and use these ensembling techniques and reduce the overfitting and underfitting problem, and you can get the optimal results, which is really helpful in building real-time machine learning models. Okay, so this is all about XGBoost. Up to now, we discussed completely about supervised machine learning is completed. Now, one more concept which takes exactly 2 days, Saturday and Sunday. As I already promised, Sunday we will cover the by Sunday we will complete the machine learning part. Right. So two concepts are left. That is, those two are nothing but algorithms. One day I will cover one algorithm, another day one more algorithm. That's it. Okay. Now we can see the second topic, second type of machine learning, which is now we can see the second type of machine learning, which is unsupervised machine learning thing. Okay, unsupervised machine learning. You can also use this content. I already mentioned you machine learning with Python. It is very minimal. Okay, it is not advanced one. It is very minimal course. You can watch the videos and you can take the notes and when so the by why because you will get the certificate at the end once you write the examination. Okay, here also the explanation is really good. I have already gone through earlier about the uh, you know clustering and all. Okay, it is really good. It is a video based one sometimes, and here DB scan algorithm is there. Okay, we will cover in our curriculum. K means clustering only. You can also learn hierarchical clustering and DB scan clustering from here. Got it? So this is also important in clustering. So there are mainly three: DB scan, K means, and hierarchical clustering. And principal component analysis is also there along with the clustering. That is what helpful in dimensionality reduction. I will explain how does it works in reality and what is the main benefit of using it in. Even that concept comes in deep learning CNN part also, dimensionally how images can get reduced, something like that. That is, don't worry. Saturday, Sunday, any one of these days, we will cover that. Okay, so now let us, okay, up to now, is it clear? Up to now, I will stop recording and